All right, hello physics students, and welcome to this tutorial for graphing in science. All right, this screencast is going to be going through how to create a successful graph specifically for science. And to do this, and for an easy way to remember how to do this, I've come up with an acronym called DETAILS. And this acronym is going to just help us remember everything that we need to create a successful, accurate, and appropriate looking graph for whatever particular data we're working with. Okay, so first, focusing on the D. The D stands for data. Basically with data, what we're really focused on is that we want to cover the entire graph area and we want to place our data accurately. Now, the reason that we want to place our data over the entire graph is so we can actually more clearly see what's going on. Okay, so if we had a data set and we graphed it like this, well, yeah, it's on our graph, but it's just a little hard to see and we're not utilizing all the space that we have. So what I would like us to do, why is it not erasing? There we go. What I would like us to do when we actually have data, we collect data and we're going to graph it, I want to use the entire space of this graph, all right? It's just a lot easier to see kind of what's going on there, and it's going to be a lot easier for us to add trend lines in and take a look at relationships that are there. All right, so next, our T in details is title. So the title, pretty basic, tells us what the graph is about. And now we need to be sure that when we are writing our title, that we are writing it as y versus x, or our dependent variable versus our independent variable. So for this graph, I'm just going to we're just going to work through this graph, and the example that I'm going to use is going to be quiz scores versus hours of sleep. All right, so it's pretty obvious here that what we would be taking a look at in this graph is how do the hours of sleep that students get affect the quiz scores. So our hours of sleep is our independent variable and our quiz scores is our dependent variable. So again, title tells us what the graph is about, and it is always written as y versus x or dv versus iv. So next in our acronym, we have the A, and the A stands for axis labels. We need to know what we are actually graphing on our x-axis and our y-axis. All right, and from class on Friday, we discussed that our IV is always on the x-axis. So our IV in this case is going to be hours of sleep. And then on our y-axis, we are going to have quiz scores. Okay, so that one's pretty self-explanatory. We just want to make sure that we know exactly what we're graphing on our x and y axis. Okay, so next, the I stands for interval. So we always want to keep our spacing constant, and we always want to start our graph at 0, 0. So I'm just going to write 0, 0 down here, and we want to make sure that we evenly space our intervals, and I'm going to try and do the best that I can here. So we want to evenly space these, because that's going to give us the most accurate depiction of our data. All right, we don't want to have, these spaced out like this, and then all of a sudden we have one that's way up here. Okay, that's just going to look silly. So we want to equally space our interval marks. Okay, so again, that's pretty self-explanatory. And really, we only have to worry about this if we're doing graphs by hand, which we will do a little bit, but primarily a lot of our graphing is going to be done using Excel. So this isn't going to be a huge concern, but we will be making some graphs by hand, so you need to make sure that you keep equal spacing between your intervals. All right, next, we're on the home stretch here. L stands for labeling the units of our independent and dependent variables. So really down here for our independent variable, I kind of already have the unit in here, hours of sleep. The unit would be hours, so we can throw that in there if we would like. So we could just put hours here. And then quiz scores, we would probably put percentage. So that is what we're going to be doing for units. And the reason that we do that is just so, well, in physics, we can gain a lot of insight as to what this data is actually telling us from our units. Okay, so it's just good practice to put those unit labels there. All right, and now finally, S, scale. We always want to go by an even scale within our graph. Okay, so for example here, a good scale would be 0, 2. Oh, that's actually wrong. There should be a 4 in there. So this should be, I'm going to cross that out because that's actually a bad scale. A good scale would be 0, 2, 4, 6, 8. So you can see there that we're going up by 2 every time. Now an example of a bad scale would be down here we go up by 0, 1, 2, and then we're jumping 2, and then we're jumping 4. That is not a good scale. That is going to make this data on our graph look very funky. Okay, so for hours of sleep, let's just go by 1. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then on our quiz score axis, or our y-axis, we'll just go up by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so really with scale, we always want to go up by an equal scale, but we also want to use a scale that makes sense. Okay, and that makes things easy for us. So hours of sleep, it's good. It's a good idea to just go up by 1 hour there. Quiz scores, it's good to just go up by tens because that gives us a little bit more accuracy. If we went up by, say, 20 or 25 to get up to 100, we might not get our data plotted as accurately as we could. Okay, so graphing in science, please remember details, particularly when we graph by hand. But again, we'll be doing both graphing by hand and using Excel. So hope this was helpful, gave you a little review about how we graph stuff. Have a great weekend, physics students. Take care.